First question, a capacitor of 4 microfarad is connected as shown in the circuit. The internal resistance of the battery is 0.5 ohm. The amount of charge on the capacitor plate will be. So a capacitor plate, okay, so here there's a resistance, internal resistance here, which is having 0.5 ohm. Okay. Now, a capacitor offers zero resistance in a circuit when it is uncharged. That is, it can be assumed as short circuit and it offers infinite resistance when it is fully charged. At steady state, the capacitor offers infinite resistance in DC circuit and acts as open circuit as shown. Like here, this part will become open circuit and there will be an internal resistance created. Therefore, no current will flow through the capacitor and 10 ohm resistance, that is part, leaving zero potential difference across 10 ohm resistance. Hence, potential difference across capacitor will be the potential difference across this point A and B. The potential difference across lower and middle branch of circuit is equal to the potential difference across capacitor of upper branch of circuit. Current flows through this 2 ohm resistance from left to right, that is in this direction, is given by I is equals to V upon R plus R, and it comes out to be 1 ampere. The potential unit 2, that is electrostatic potential and capacitance difference across this 2 ohm resistance, we have the formula V is equals to IR, that is I we found out, that is it is 1 ampere. So 1 into the resistance of 2 ohm, which gives out to be 2 volt. Hence potential difference across capacitor is also 2 volt. Now the charge. So charge is equals to CV, which is equals to C is given the half 2 microfarad and volt comes out to be 2 volt. That is potential difference, and therefore charge is equals to 4, which is given in the question, 4 microfarad capacitor. So this comes out to be 8 microfarad or microcoulomb, farad and volt, which gives you coulomb, that is a charge. So correct answer among this question is option D, that is 8 microfarad. Looking towards the next question, a positively charged particle is released from rest in a uniform electric field. The electrical potential energy of the charge. So electric potential decreases in the direction of electric field. The direction of electric field is always perpendicular to the equipotential surface maintained at low electrostatic potential. The positively charged particle experiences electrostatic force along the direction of electric field on the charge. Now we know hence electrostatic potential energy of a positively charged particle will going to decrease, and thus the correct answer is option C. Looking towards the next question, that is equipotentials at a great distance from a collection of charges whose total sum is not zero are approximately. So the collection of charge whose total sum is not zero with regards to this great distance can be considered as a single point charge. The equipotential surface due to a point charge are spherical in nature. Important point is to understand that the electric potential due to point charge Q is given by V is equals to Q upon 4 pi epsilon naught R L T. Means electric potential due to point charge is same for all equidistant points. The locus of these equidistant points, which are at the same potential, form spherical surface. So correct answer for this question is option A, that is sphere. Looking towards the next question. A parallel plate capacitor is made of two dielectric blocks in series. One of the block has thickness D1 and dielectric constant K1, and the other has a thickness D2 and the dielectric constant K2, as shown in figure. This arrangement can be thought as a dielectric slab of thickness D equals to D1 plus D2. The effective constant K is find out then. Here the system can be considered as a two capacitor C1 and C2 connected in series as shown in the figure. The capacitance of the parallel plate capacitor filled with dielectric block has thickness D1 and dielectric constant K is given by. So we have some basic formulas in relation, that is 1 upon C equal, that is equivalent, is equals to 1 upon C1 plus 1 upon C2, and therefore it is C1 into C2 the whole upon C1 plus C2. By substituting all the values, C equivalent come out to be K1, K2, epsilon naught A the whole upon K1 D2 plus K2 D1. Now looking towards the option, and thus the correct answer for this question is option C. Okay, we can substitute this epsilon naught A and all. Now we know that C is equals to K epsilon naught A upon D1 plus D2, and when we substitute this epsilon A value over here, it comes out to be C equivalent, or comparing these two equations, we conclude that K is equals to K1 K2 D1 plus D2 the whole upon K1 D2 plus K2 D1. Thus the correct answer for this question is option C. Now looking towards the last question, the electrostatic potential on the surface of a charged conducting sphere is 100 volt. Two statements are made in this regard. S1, that is statement 1, at any point inside the sphere, electric intensity is 0. And second statement, at any point inside the sphere, the electrostatic potential is 100. Which of the following statement is correct statement? So we know the electric field intensity E and the potential electric potential V are related to E is equals to dV upon dr. Now if electric intensity E is equals to 0, then dV upon dr is equals to 0. It means E is equals to 0 inside the charged conducting sphere cause uniform potential inside the sphere. Hence uniform potential 100 volt will be at any point inside the sphere. So correct answer is S1 is true, S2 is also true, and is the cause of S2. S1 is the cause of S2. This is S1 is the cause of S2. Therefore the correct answer is option C.